Hello and welcome back. Today we're going to talk about molality and mole fraction, which are both uh, ways we can calculate concentration. So to start with, molality, which is designated with the lowercase m, is the number of moles of solute dissolved in 1 kilogram of solvent. So we're looking at moles of solute divided by kilograms of solvent. So you're going to moles of solute again over kilograms. Your units are going to be moles per kilogram, or molal, which is MOL. To do this, you're going to need to know that the density of water, which is our most common solvent, and I will tell you if it's not water, I'll tell you what the density is so you can calculate it. The density of water is 1 gram per milliliter or 1 kilogram per liter of solution. Those are going to be two very important conversions for you to remember and utilize. For example, in this question, we're going to calculate the molality of a solution created by dissolving 0.750 moles of sodium hydroxide into 500 milliliters of water. And so remember, molality is equal to N, which is moles, over kilograms of solvent. And so I know that I have 500 milliliters of water. And I also remember from the last slide, the density of water is 1 gram per milliliter. So I know that I have 1 gram for every 1 milliliter. And if I set it up this way, I get my units to cancel out. Milliliters are on top, milliliters on bottom, which leaves me with grams on top. But I need my final answer in kilograms. So to go from grams to kilograms, I need to know that 1 kilogram is the same as 1,000, or 10 to the third grams. Now I'm going to use 2 bars for my equal sign. So if I take 500 times 1, and then my grams on top and grams on bottom cancel, times 1 times 1, that gives me 500. And 1 times 10 to the third is the same as 1,000. And because I'm left with those units, I have kilograms on top. And so I can take 500 divided by 1,000 to get 0.50 kilograms. And so now if I go back up to my original equation, I know that I have 0.750 moles of NaOH. And I'm dividing that by my kilograms of solvent, which is 0. Add another 0 on this one, 500 kilograms of H2O, which is going to give me 0.75 divided by 0.5, is the same as times 2. So my answer is going to be 1.50 molal, which should just be a lowercase m. And there's my answer there. Our next one, our last concentration calculation is going to be mole fraction. Mole fraction and mass percent are very similar. So for mass percent, we took grams of solute divided by grams of solution. Here we're taking moles of solute divided by moles of solution. You can leave mole fraction as a decimal. We don't need to make it a percentage. We want the decimal version. Which means that because we have a decimal, I should be able to get answers of less than 1, because if I would take the mole fraction for both my solute and solvent, they should equal 1 as the whole, because that would be 100%. So let's look at a practice example of this, and then we'll continue on. So here we go. The question is, What is the mole fraction of ethanol in a solution prepared by dissolving 100 grams of ethanol, which is C2H5OH, in 100 grams of water? So again, my mole fraction is equal to moles of solute over moles of solution. So given that I have grams in both, I need to convert those. So I'm going to take 100 grams of ethanol. I'm going to divide it by the molar mass, which is 44. Oh, let's go 12.01 times 2 plus 1.01 times 6 plus oxygen is 46.08. And so if I take 100 divided by 46.08, I'm going to get 2.17 as my moles here. And that's going to be divided by my moles of water, which is going to be 100. Divided by, oops, this is grams of water. Divided by 18.02 grams per mole of water. 100 divided by 18.02 is 5.5. 5.55 moles of water. Actually, should be 5.549 to go sig fig. So we'll make that a 4 and a 9. So this is my 2.17, which should also have 4. So there's a 0 after the 7. To fix that. And I'm going to divide this by 2.170 plus 5.549, because that is my moles of solution, which is moles of both. So if I take 2.17, 0 divided by parentheses 2.170 plus 5.549, I'm going to get an answer that is equal to 0.2811. And this is my mole fraction. That's going to be my answer. And that's how you do mole fraction and molality. That's all for today. We will pick up from here tomorrow on our next lesson. Until then, enjoy your afternoon, and I'll talk to you guys later.